Welcome back to my channel. This is another video on the logic gate expression. This question looks rather simple and straightforward. It is taken from October-November 2025 paper 2-2, that is IGCSE Computer Science. So here we are required to draw the logic circuits for the logic expression. This one here. Each logic gate must have a maximum of 2 inputs. Do not simplify the logic expression. Okay. So let's just quickly do that. I'm going to be drawing this with my touchpad, so it may not look beautiful, yes? So let's do it bit by bit. So we can start with this first or start with this first. It doesn't really matter. Okay, so let me start with the knot L, okay? So that's the NOT gate. So this here is NOT L. So we now need to go inside of this bracket and work our way out. So if you watch the S OR gate or the exclusive OR gate is the uniting factor for this and that. So we need to do the NOT K first before we will now add the exclusive OR gate with the J input. Okay. So here's K, another NOT gate, sorry. So this here is the NOT K. So we now need to join this, okay? So we need to add it to the S OR gate, okay? So, okay, so that's the shape of the S OR gate. Let me just redraw this so that the circle looks neater. All right, so we're done with this part. Now the next part is to join the left-hand side and the right-hand side to a NAND gate. Okay, so the NAND gate is an AND gate with the sign of inversion in front of it, okay? So you can carefully take out this. Let me remove this carefully. I don't know if that will work. So since you're drawing with a pencil, your drawing should be a lot neater. Now, from my record, over 90% of you who watch my videos are not subscribers, and that is a staggering figure. So I want to use this opportunity to remind you to subscribe, like, share, hit the notification button, and even comment. That way this video gets to as many persons as possible, and we are encouraged to do more. Now, have you done that? Thank you. Let's continue. So I have simplified the table in a way that we can do it progressively and avoid mistakes as much as possible. Okay, so I broke them down. So if you notice, this is the entire equation that was given to us, or the expression. Okay, here we have it. So I broke it down. I came on the inside and I brought out NOT K, which is this one here. I brought out, and then I have the J, ZO, NOT K, which is this one here. So this is the left hand side, and then we have this as the right hand side. Okay, then after that we can now do the final thing here. Okay, so that way it is simple and straightforward in order to avoid mistakes. But if you have a way to just do it straightforward, it's still fine. But I like to break it down this way, and I equally encourage my students to do the same. That way you are certain that you have eliminated all the possible errors that you could have. Okay, so let's get it done. Not K. So all you need to do is to invert everything you have here. Yeah. So where you see 0, put 1, 1. Okay, so when you're done, you quickly run through it again to confirm that everything is okay. Okay, 1, 1. Okay, so this looks good. So let's now proceed to the exclusive OR of this and then the J. Now, take note that for the exclusive OR, you are looking at the number of ones. If the number of ones is an odd number, then the output will be 1. If it is an even number, then the output will be 0. You understand me? Okay, so bear it in mind that we're looking at J and not K. Okay, these two of them. Okay, so J exclusive of not K. So 0, 1. So the number of 1 here is 1. So that's an odd number. So 1. Here, the number of 1 here is 1. It's an odd number. So 1. Number of 1 here is 0. And 0 is an even number. So the output will be 0. The same thing here, 0. The number of 1 here is 2. And 2 is an even number. So the output will be 0. Again, even number, 0. Odd number, 1. And then odd number, 1. Okay. So since we've done that, we now need to do the not L. So you invert everything here as well. So you need to approach this with some level of care because it is easy to make mistakes here. So that's why we need to double check, okay? So we're dealing with L, right? So 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0. Okay. So we're now left with this last part, okay? So what we need to do now is to NAND this and that, okay? So you see, by doing this, you have simplified it as much as possible. So we now need to NAND it. And remember how the NAND gate works. The NAND gate is the AND gate with a NOT gate in front of it, okay? An AND gate with a NOT gate in front of it. So since you have that in mind, you will do your AND first and then you invert the result, okay? So 1 and 1 is 1. When you invert it, 0. 1 and 0 is 0. You invert it, 1. 0 and 1 is 0. You invert 1. 0 and 0, 0. Invert 1. 0, 1, 0. Invert 1. 0, 0, 0. Invert 1. 1, 1, 1. Invert 0. And then 1, 0, 0. Invert 1. So go back again and double check just to be sure that everything is okay. 1 and 1 is 1, invert 0. 1 and 0, 0, invert 1. 0 and 1. Okay, so with this, I think we're done with the question. Okay, so quickly comparing it with the math scheme, you would see that we're good to go. Okay, that's that, that's that, that's that. Yeah, and then let's look at the truth table as well. All of these doesn't matter, it's just a working space. Okay, what matters is your final answer. So let's confirm. Okay, so this looks okay. So with this, we've gotten all the 8 points. Okay, well done, guys. Good job. Now, have you liked? Have you shared? Have you subscribed? Please, if you've not, find time to do that. Okay, that way this video gets to as many persons as possible. Right. Do well to comment, please. If there's anything you want us to do, any video, any year you want us to look at, please feel free to do so. We'll consider it and we'll make a video about it. Thank you, guys. I'll see you guys again in the next edition. Bye for now.